Okay, welcome guys. So this video, I want to talk about Eisenstein Criterion. So we will prove the Eisenstein Criterion. And before I start, please subscribe to my channel. This is my channel. Click the subscribe button down below, and yeah, comment. Click like button, click subscribe button, and click the bell below, and comment on whatever you like. Okay. So let's talk about Eisenstein Criterion. Yeah, so this is the basically the I think undergrad algebra, right? And very easy to prove. So let's quickly prove it. So idea is that you have a polynomial with n xn with degree n as a single variable x, and suppose there is the prime p such that p divides a0 up to an minus 1, and the p squared do not divide a, but p squared do not divide a0, and the p do not divide an. Then f is irreducible in Q. So that means that you cannot write f as a gh such that the gh are degree or greater or equal to 1, and they are both in the rational coefficient. So this is just saying the corollary is that f does not have the rational roots. Okay. Right, and the proof is so amazing that I mean, it's obviously that not easy to think about this criterion. Okay, so let's write G as this B, BD XD, BD minus 1, XD minus 1 up to B0, and H is CE, XE, CE minus 1, XE minus 1, C0. Okay, so my mathematics is, so the simple mathematics says that A0, right, the first constant coefficient, will just the product of these two. Right, and the height is the coefficient an will be the product of BD and CE. So this is trivial, right? But we know that the p divides a0, but p squared do not divide a0, right? So p squared do not divide b0 times c0. So let's assume that p divides b0 and the p do not divide c0. Okay, how about a1? So a1 will be a cross term, right? So a1 will be b0 times c1 plus b1 c0. So important is that ap divides a1, right? And the p also divides b0. By assumption, and we know also that p do not divide c0, so that means p divides b1, right? Because both these two are can be divided by p, and so this guy will divide by p, right? But c0 is not divided by p, so yeah, so b1, yeah, so b1 is b1 is p divides b1, okay? Yeah, so p divides b1, right? And how about a2? A2 is b0, c2, b1, c1, b2, c0. So the same reason, this guy is the multiple of p, and since p divides p1, so multiple of p, and p divides a2 by our assumption. So c0 still not divides p, right? So combine these two, we know that p divides b2, right? So keep going, we know that p divides b0, b1 up to bd, right? But we know that an is bd times ce, right? So p divides b, so p divides an, right? But this contradicted of our assumption. Okay, so this is like a very canny example that you think some easy criterion, some strange criterion, and you prove that this is actually will give you the irreducibility of this kind of polynomial in rational roots. Okay, so I think that's very easy. I don't want to talk about example, right? But yeah, because it's just very easy. I will see you guys in the next videos.